Hello, calculus fans. Let's take this curve where the I component is 2 over t squared plus 1, quantity minus 1, and the j component is 2t over t squared plus 1. We're going to reparameterize this with respect to arc length. We're going to measure from the point 1, 0 in the direction of positive t. And we're going to express this reparameterization in its simplest form. One thing to take note is as you look at this curve as stated now, you probably have no idea what it really looks like. Notice that at the point 1, 0, the t value is 0. And if we compute a derivative, we'll get this expression. You should check to make sure that we've applied the quotient rule correctly. Now, we're going to find the arc length function. In order to do that, we need the length of r prime. So I've computed that here. Bit of a mess. We're going to try to simplify this a little bit. We multiply everything out in the numerator. We get an expression that looks like this. And now let's clean this up. If you work out what's in the top, it's actually a perfect square. It's 2 plus 2t squared squared. Not sure about that? Multiply all this out and see that it matches up with this. Well, now we've got a fraction where the top and the bottom have even powers, and we need to compute a 1/2 power of the whole thing, so that's actually pretty straightforward. We get something that looks like this. And notice that the top is just 2 times 1 plus t squared, so everything cancels out with one of the t squared plus 1's in the bottom, and we get this very nice looking expression for the length of r prime of t. Now we're ready to compute what the arc length function is. So we're going to integrate from 0 to t of the length of r prime of u. That's the integral from 0 to t of 2 over u squared plus 1 du. So keep in mind that u is the variable of integration, t is a parameter value. And you should recognize that an antiderivative of 1 over u squared plus 1 is arctangent. If you plug everything in, then you end up with that the arc length function is 2 arctangent of t. All right, now what are we going to do with this? Remember what our goal is. We're trying to reparameterize with respect to arc length. So in order to do that, we have to solve for t in terms of s. So if we do that, we end up with t equals tangent of s over 2. Now let's write down the parameterization with respect to arc length. Essentially, what we're going to do is go back to our very original expression for r, and every time that we see a t, we replace it with tangent of s over 2. And we get an expression that looks like this. Now we're going to do some trigonometry to try to simplify this, basically using some trig identities. For example, tangent squared of s over 2 plus 1 turns into secant squared s over 2. More simplification, the I component turns into 2 cosine squared of s over 2 minus 1. The j component, if you just work out tangents and secants, you end up with 2 sine s over 2 cosine s over 2. And both of these can be worked out using a double angle formula. We can double the angle and end up with cosine s times I plus sine s times j. If these are not trig identities that you're familiar with, you may need to go back and review some of these trig identities. Now remember at the beginning, we had a parameterization that I considered to be somewhat opaque. That is to say, if we looked at the original parameterization, we really had no idea what the curve was. But now, you easily recognize this parameterization as a circle. After all, this is the standard parameterization of a circle. So we change parameterizations, and suddenly we actually get something that's simpler to see. Now that doesn't always happen, but the one thing that this parameterization does is it gives us a parameterization with respect to arc length. Parameter values now aren't just arbitrary points on the curve, they tell us how far we're moving along the curve. And in fact, in the standard parameterization of the circle, that really should make sense because arc length on a circle is an angle. That's really the definition of an angle when you're talking about angles in trigonometry. Okay, that's all for now.